In this lecture, we're going to continue our previous discussion of how to find the equation of a parabola, given information about it, by looking at situations where all you have are the coordinates of points that have to be on the graph, or in algebra terms, that have to satisfy the equation. So this is a situation that comes up in fields like numerical analysis, data analysis, and statistics, where you have data that you acquired from some kind of experiment. You need to find a curve that models those values. Right? So thinking about parabolas, the first question we have to ask is, how many points do we need to have to guarantee we only have one possible result? Well, hopefully it's obvious that one point isn't going to do. There are infinitely many parabolas that we could draw just with that point as the vertex, going off in infinitely many directions. So how about 2 points? Well, unfortunately, in the general case, that still isn't going to be enough. I could draw one parabola here opening down, but there's another parabola going through those same points opening in the opposite direction. So again, in the general case, the answer to my question is going to be that we need 3 points to uniquely determine a parabola. Now, there is a special case where you can get away with only knowing two, but we're going to look at that one in the next lecture. Now, even if you know 3 points, that technically still isn't enough to answer the question, right? Because with these 3 points here, I could draw a parabola opening down, right? Or through those same 3 points, I could also draw a parabola opening to the right. So 3 points is going to be enough for our purposes, but we are going to have to add one extra piece of information, and that is in which direction our parabola is opening. So how about this situation here? I want to find the equation of the parabola through the points 0, comma, -3, 1, -1, -2, -1, and I'm going to assume that the parabola opens up and down. Okay, remember, for an up-down opening parabola, our equation looks like x minus h squared equals plus or minus 4a, depending on the direction, times y minus k. Well, we could work with that equation, right? We could. It'd be a little messy, but we can get away with it. Uh, in practice, what we're going to do is I'm going to say, look, this is a quadratic equation, right? If I multiply out the left and right sides, I rearrange the terms, I solve it for y, I'm going to get a quadratic equation. And the general form of a quadratic equation is y equals ax squared plus bx plus c. Now remember, that a is different. Okay, that a is not, this a over here is not the same as this a over here. Unfortunately, it's two different parameters used in different contexts. So to answer this question, I'm going to use that equation. Right, and here's what I'm going to do. I'm going to take my 3 points, I'm going to substitute them into that equation and see what happens. Right, so if I put 0, comma, -3 into that equation, I get -3 equals a times 0 squared plus b times 0 plus c. And if I put 1 in there, -1, I get -1 equals a times 1 squared plus b times 1 plus c. And finally, if I put -2, -1, I get -1 equals a, be careful with the negatives, -2 squared plus b times -2 plus c. All right, so let's take these in and simplify, clean up all that arithmetic. Right, this one is nice. This one gives me -3 equals c. It's like one of my 3 parameters almost for free, right? Just from having a point that happened to be on the y-axis there. Now, if I simplify this next equation, I get -1 equals a plus b. And I'm going to go ahead and put that -3 in there. And then if I simplify this third one, I get -1 equals 4a minus 2b minus 3. Right, and hopefully this is starting to look familiar. Right, I'm going to go a little further. I'm going to solve this. I'm going to get the constants all on one side. So this is a plus b equals add 3 to both sides. That's 2. And this one is 4a minus 2b equals, we'll add 3 to both sides. And we get 2. Yeah, okay, I can go one step further. Divide this 1 by 2. 2a minus b equals 1. Right, now just bring this one over. A plus b equals 2. And we have a system of equations. Right, system, 2 equations, 2 variables. Awesome. And you see I've got that b and the minus b. I can just add these 2 equations together. And we get 3a equals 3, or a equals 1. So now I have 2 of my 3 parameters, right? To get the third one, I'm going to take a equals 1. I'm going to substitute in this equation here. That gives me 1 plus b equals 2. So b is equal to 1. And now I have my answer, right? I'm going to take those values for a, b, and c. I'm going to drop them into that equation there, and I get my solution. Y equals x squared plus x minus 3. And you can check, right? Really quick, if you like, you can check real quick, substitute all 4 of those points into that equation, and all 3 of them should satisfy it, right? So there's my answer. And in general, this is the answer you're going to want. You're going to want it in this kind of multiplied out generic quadratic equation form. Obviously, we could take this and apply our previous techniques and find things like the value of the location of the focus and the directrix and all those other things. But that's not what the question asked for. The question just said find the equation. I've done that, right? So we're ready to move on to the next thing. So I've got another example for us here, and this one is a little different. This one opens left to right instead of up and down. So the procedure we follow is fundamentally going to be the same. The key difference is just going to be the equation that we use. Right? You remember that the left to right equations, those have y squareds in them. So the equation that I start with here will be x equals a y squared plus by plus c. Right, now I'm going to put my points in here. I'm going to be really careful about this because we're so used to the which side the x goes on and which side the y goes on. It's easy to get them mixed up here. So I'm going to put 0 in here for x and 1 in here for y. So the left side will just be a plus b plus c. Now I'm going to put negative 15, negative 2 into that equation. So negative 15 equals negative 2 squared. That's 4a minus 2b plus c. And then I'll do negative 3 comma 2. That's negative 3 equals 4a plus 2b plus c. All right, so now I didn't kind of get one of the parameters for free like I did in the previous equation. So I have a system of 3 equations and 3 variables, and we know how to solve this kind of thing. I'm going to start combining the equations together to eliminate one of the variables. And one of the nice things about this particular kind of problem, you're always going to have these plus c's at the end. Right? So that's almost always going to be the variable that I choose to eliminate. So I'm going to start by combining the first and second equation together. Right? That'll be a plus b plus c equals 0. I'm going to subtract the second one. Minus 4a plus 2b minus c equals 15. So this will become, the c's go away, right? Minus 3a plus 3b equals 15. And I can simplify this one a little bit, right? Let's divide everybody by 3. And we get minus a plus b equals 5. Okay, so now let's combine the second and third ones together. I'm gonna leave the first one alone. 4a minus 2b plus c equals negative 15. And we'll subtract the second one. Minus 4a minus 2b minus c equals positive 3. And look, we got lucky on this one. The a's and the c's are both going to cancel. We get minus 4b equals minus 12. So b equals 3. All right, so we did kind of get lucky, or maybe not as lucky as the first one. but that was still kind of nice. So now let's substitute that into here. This will turn into minus a plus 3 equals 5. So minus a equals 2. So a equals negative 2. And now I'm going to take these two values and I'm going to put it back into the first equation, right? That a plus b plus c equals 0. So we're starting with a plus b plus c equals 0. And I'm going to put negative 2 in there for a, 3 in there for b, plus c equals 0. Negative 2 plus 3 is 1. Move that over to the other side, and we get c equals negative 1. And that's what I needed. Right now I have all three parameters. So the equation of the parabola opening left, right, that passes through those points is x equals negative 2y squared plus 3y minus 1. Back on the first slide, I said there was a special case where you could find this equation even if you only know 2 points instead of 3. Right? So that's what we're going to look at in the next lecture. We're going to look at that case and kind of see how the equations that we've been working with here relate back to the vertex form that you may have learned about in a previous algebra or maybe a pre-calculus class.